Okay, I should start. We have 55 participants. So good afternoon, everybody, for joining the sixth session and the last session of the fifth International Symposium on Occupant Behaviour, organized by the Sustainable Energy Research Group at the University of Southampton. Just as all the sessions, this session is being recorded. So I'm Stéphanie Gauthier. You probably might have had some email from me. I'm the co-chair of this symposium. I'm a lecturer in energy and building at the University of Southampton, and I would be chairing this last session on case study of occupant-centric modeling. As attendee, please ask some questions through the Q&A. I will be sharing this session and then see with regard to time, whether ask question at the end of the presentation or within the discussion panel. So for general conversation, please use hashtag Annex79 or OC20. Otherwise, please, when asking questions, let me know which presenter you ask a question to. So the format is similar to the other session. We have 3 8-minute presentation and 4 3-minute presentation, and a 25-minute Q&A session to all presenter. I'll be quite strict with regard to time, so we can just, if people from far away are just logging in to see a specific presentation, then at a specific time, then they can view the presentation. So without further ado, I would like to introduce our first speaker, Niels Lassen for the Norwegian University of Science and Technology, and his topic is subjective data stream for indoor climate assessment in buildings. Niels, up to you. Thank you very much.
Yes, hello everyone. Thank you for having me. So I'm going to try to present almost a whole PhD thesis in 8 minutes. So it's going to be very brief. But I'm hoping for feedback. That I guess that's the general idea. So please ask questions if you find anything interesting. So the background of my thesis is that I'm working at Skanska, Norway, as an energy consultant, and we've been working with several holistic plus energy buildings together with the Snøhetta, among others, and several others. And we have discovered that discipline-specific performance criteria, they lead to quite suboptimal solutions in some cases when we're trying to design these buildings. We've also discovered that there's a performance gap, or we know that there's a performance gap between occupant satisfaction and also energy performance between what we think we're designing and what ends up in the end. We also know that there's a low information flow from the use phase of a building to the design phase. So we don't know a lot about how our buildings are received by the occupants. So the question is, can we use subjective occupant feedback to learn from the buildings we design and further support these holistic design choices? So this is quite a practical approach. It's a model-free approach. It's about the collection of data and not so much about what we can do with it later, more trying to find out how can we collect data and what's the value of the data. We've also been focusing mostly on non-intrusive data collection. So our customers don't want to annoy the users with data collection because they are concerned with very many other things than just indoor climate. So the research question, the general research question for the PhD is, can continuous non-intrusive collection of subjective data from occupants outperform traditional deterministic comfort models? And also post-occupancy evaluation, and can they bring added value to building benchmarking, tuning, control, and design? So those are the 4 areas we've focused on. So from that, we started to look at what can we collect without asking the user. How can we tap into some data from the user? Of course, the physical data. we also collect at the left. I've used this psychological feedback loop from the Dear, Bragg and Cooper to kind of look at different levels we can collect data. So the physical environment, that's easy. We do that already. We've used some IoT sensors and combined them with built-in building sensors. We know that many collect data from a physiological level, from smartwatches or IR cameras and so on. We know that we can collect data from user actions, like if you open a window, probably you needed fresh air. If you turn a light switch, probably you thought it was too dark. We can also do that on another level with kind of feedback apps or personal comfort devices, like the chair experiment here from the UC Berkeley. But then we also wanted a higher level of evaluation from the users, evaluation of the satisfaction, and that's more difficult to tap into a stream. So we have to ask the user. So we ended up with a system of 3 different levels. One is the physical level to the left, which is already in place mostly. And then we have a sensation, complaint, or control action level, which is a right now personal information stream, where we've tested both personal heaters and the use of them, and some use of QR codes and smartphones. And then we have a total satisfaction level where we used these polling stations, smiley face polling stations, which have been quite popular in retail and airports and so on, and seen if we can use those in a building setting. There are also some other studies who have done similar things. Those also, in some cases, had a follow-up screen. So if you are dissatisfied, then that question would come, what are you dissatisfied with? We've done quite a wide theoretical study, but and I won't go into it, but we've done a review of field studies on subjective occupant feedback. So only field studies and only those who have contained subjective information. In that study, we found that this, trying to categorize the systems, we found that the participatory sensing apps were quite popular. So these voting apps that vote for a general environment in the building, not for a personal environment. We also have apps doing more personal feedback, where you also can combine with telling stuff that's not working or making comments. There are some personal comfort systems used as feedback, but not many. There are some polling stations used, but not many. And then there are intelligent thermostats, which are also, there are some. We've also done a general study into occupant psychology, trying to kind of distinguish these different levels of feedback from each other, and then taken the viewpoint, which is also taken by some other comfort researchers, looking at the occupant as a consumer of the indoor climate. So then looking into market psychology and also other types of psychology, trying to connect this to a more broader psychological standpoint. We've done now 6 field experiments in office buildings. We've limited the study to office buildings, actually. 4 of them were in Norway and 2 were in California, while I was at the Center for the Built Environment. 2 of the buildings were hybrid plus energy buildings, and 4 were mechanical, more or less standard, both old and new buildings, also mechanically ventilated. So then we collected data from both this system, which I described, and we also performed occupant surveys, where we approached each occupant with an iPad and asked them, had them fill out questions on the iPad, taking maximum about 2 minutes. Some of the questions were equivalent of those found on the polling station, and some were equivalent of the POE studies, taken from POE studies. We also did temperature interventions in some of the buildings, and we tried to keep the subjects as uninformed as possible, so that they wouldn't affect this other, or that they would act as a normal occupant would. They were not informed of the real intent of the study. There are some pictures showing the polling station in the top right, and then we have a personal heater mounted. We mounted more than 100 of those under a desk, and a floor plan showing temperature sensors, and red is the polling stations by exits in one of the buildings. So the collected data we've surveyed a total of 200 people in all of the buildings at different sizes, and in some buildings we only took a few rooms. We have 2,800 total responses on the polling station, while 403 of them were on days where we also did a survey, because we didn't do surveys on all days. Of those, 143 were complaints on those survey days. The QR feedback wasn't very successful. People didn't take it much into use. So we had only 2 responses which we can match to surveys. The heater, on the other hand, was very popular, especially in the manual mode, where people did not have to go through a smartphone to use it. Using a smartphone for these kind of small actions was actually not that popular with many of the users. And we have a total of 628 surveys performed among the users. Of course, several repeat users, as many buildings had up to 5 surveys. So some of the findings here from the polling station, we found that the use of the polling station stabilized at about 20 to 40% of the building population per day. So if they voted, assuming that they voted once per day each, that would be about 20 to 40% of them voted each day. And we had that consistently for about 2 months in the longest studies, but it was very variable. We had a large and variable non-response bias, which means that dissatisfied voters vote more than satisfied or neither satisfied or dissatisfied voters do. You see in the top figure here that the light blue is our ground truth, the survey where we have asked occupants the same question, while the darker blue is the SPS, or the polling station. And we see that dissatisfied votes, we have much more votes. And we've also found by asking the subjects that some of those most dissatisfied voted more than 3 times a day. So that's a major concern. And this effect was very variable between buildings, so it's hard to say how large this effect is beforehand. On the other hand, we found a high correlation between the thermal complaints, looking just at thermal complaints, and the temperature interventions, or the temperature, and also the survey responses to dissatisfied users. So here we see in the bottom figure by the red arrow, we see one day where we had the temperature intervention and reduced the temperature by 2.5 degrees. According to using the PMV and PPD model, it didn't predict that people should be very dissatisfied on this day. And the round dot is the number or the share of dissatisfied respondents on the survey, and the line is the share of dissatisfied users on the polling station. And we see that the polling station actually follows the survey quite well. So there was a high correlation coefficient between those 2 sources.
Niels, sorry, could you please conclude?
Yes. So to sum up, it was easy to make this system. It's made of off-shelf components. And the information collected had a high value for building tuning, especially, also control and building design. But it could also be used for benchmarking, but you have to correct for this non-response bias, which is quite difficult. There are differences between user groups in how they respond. And we also found that we're missing a framework to classify the data that we are collecting. So what kind of data is it? Where does it come from? Is it evaluation? Is it a preference? Is it like physiological data? We find that we should actually have some kind of way to classify this kind of information. Thank you.
Thank you very much, Neil, for the presentation. We'll to our third speaker, Lucile Sarran from Technical University of Denmark, and she's going to present on learning to live in low energy dwelling, a mixed method case study. Learning to live, really interesting. Thank you.
Yeah, thank you very much. So my name is Lucile. I'm a PhD student at DTU in Denmark, together with the company Saint-Gobain. And I'm going to present you a case study about low energy dwellings and how occupants have to learn to live in them. So we know that perceived personal control has an influence on the way people perceive comfort itself. And we often assume that in private dwellings, personal control on comfort is high because people have basically the upper hand on what the systems can do. But actually in new and retrofitted dwellings, we see more and more kind of complex building services, automated services that are not unlike what we see in commercial buildings. And there have been several post-occupancy evaluations that showed that some of the systems presented usability issues, usability being defined as the ability of people to achieve their goals with effectiveness, efficiency, and satisfaction. So basically the question is whether these usability problems also have an impact on perceived personal control. So we did a field study with 3 research questions. The first one was simply to evaluate how people experience their indoor environmental quality when they move in a low energy dwelling, and then how do they experience the usability of the building services. And the last thing was, is there a link between indoor environmental satisfaction and perceived usability? So the methodology was to use a mixed method case study, meaning that we had a quantitative part and a qualitative part. And the quantitative part was made through a questionnaire where people were asked to report their satisfaction with thermal comfort and indoor quality, and then usability of heating systems and mechanical ventilation systems. This was made in Denmark, so there is no cooling or air conditioning. For the analysis, we aggregated the original questions into 9 latent variables that I will describe later, and then we analyzed how these variables were distributed and how they were correlated to each other. And for the interviews, so the goal was to get a little bit deeper data on satisfaction and understand a little bit more routines and expectations and how people actually behave in these buildings. We recorded the interviews, we transcribed them, and then the coding was done thematically, but also trying to keep the line of occupant stories. So what the results show, so the case buildings are 2. One is a social housing complex of about 2,007 houses. The red areas here were buildings that were not retrofitted at the time of the study, and the other 3 were retrofitted within the past 5 years, so we could evaluate the impact of the retrofit. And the case 2 was new apartments that were quite high-end. They were also owned by their occupants, so it was kind of a different story. And we sent the questionnaire to the social housing dwellings. We got 344 replies back, so all in all 17%. And the interviews, we made 29 in the social housing complex and 14 in the new apartments. So the results show, so the first part of the results is about thermal comfort and heating, and the questionnaire variables, the aggregated variables are these 4. So we can see that type A, B, and C houses, which are the retrofitted ones, were overall very satisfied with the indoor temperature. You can see the satisfaction score from 0 to 1 here. So they were overall very satisfied with the level of indoor temperature. They were also satisfied with the stability of temperature, way more than in the non-retrofitted houses. So this is nothing new. We knew about this. Then we asked about the usability of these services. And we can see that the average usability for type A, B, and C is around 0.7, 0.8. So it's not like the same level of satisfaction as, for example, the indoor temperature. And as to the way people prefer to control their heating, we can see that the house type that gives the most satisfaction were the houses that had floor heating with a programmable thermostat. And for the other retrofitted houses, we can see that the preference was towards more manual control than what they had. The interviews gave, well, some of the same results. So temperature was comfortable, it was stable. For those that had floor heating, it was pleasant to have a warm floor, to be home without sleepers and so on. There were also a lot of complaints, mainly about overheating in summer in all the retrofitted and new houses. And then floor heating was also perceived as too slow by some of the occupants. And the problem being also that basically when the temperature has reached a set point, the floor is not warm anymore. And that creates yes, that creates dissatisfaction in itself, so it led to increased set points to actually keep a warm floor. And overall, occupants felt there was a lack of information about efficient heating operation. And as to indoor quality and ventilation, so these are the aggregated variables. We can see that satisfaction with indoor quality in the 3 retrofitted house types is really high. This was not asked for non-retrofitted houses because they didn't have ventilation. This question, air supply process, is related to the ability of ventilation to provide air without noise and draft. And we can see that the type of house where it was the most satisfying was where the air was supplied at the floor level and the radiators. Some of the houses experienced air dryness because of ventilation, also dust projection from the inlets. And as to usability and control of the ventilation system, the type of houses that offered the most satisfaction was where there was a CAV, so constant air volume, but there was a turbo mode that was moisture controlled with the possibility of manual override. The interviews showed that ventilation indeed was making the air fresher and healthier, and airing was less common as before. But there was a large problem with automated operation because ventilation was mostly constant air volume in all types of houses. And people were told not to touch the systems. They couldn't really do anything when they had noise and draft problems. And that meant that they basically were taking back control and taping the diffusers, putting paper on it, magnets. They were very creative. Some of them would just switch off the power supply. And some of them also reported that maintenance people that they called to help also found hacks because they couldn't control the systems themselves. So the next thing we did was to have a look at the correlation between the comfort variables and the usability variables. So you can see on the x-axis the usability variables for heating and ventilation, and on the x-axis the corresponding comfort variables. And we did the Spearman correlation study here, so you can see the correlation coefficients up here. They were significant, they were relatively high. So we can see that there are significant correlations between indoor environmental satisfaction and usability satisfaction. But actually the real question is whether there is a causal relationship. So the hypothesis we're actually trying to test is whether a high perceived usability is a necessary condition for comfort. And to answer this question, we can actually have a look at the distribution of points on these 4 graphs. And we can see that most of the points are located in this top part of the graphs here. And that means that a lot of occupants were satisfied with the indoor environment, but they still were rating poorly the system's usability. So we can pretty much answer that high perceived usability in most houses was not a necessary condition for comfort. So is there a causal relationship here? The interviews gave us some extra insights because actually a lot of occupants said that they managed to achieve satisfactory comfort without really touching too much the building controls. So just with passive house quality and automated features. And when there were complaints about lack of manual control and lack of usability, it was mainly when the systems were not working as intended or the operation settings were wrong from the start. So basically it was the bad indoor air quality that was triggering the dissatisfaction with usability. So as discussion and conclusion, so of course the studies may be not representative because we had a limited response rate and it was maybe all the population and the general Danish population. And we should have done a shorter questionnaire. That's definitely a top learning for next time. And as to the conclusion, so we know that these houses retrofitted or new provide a large indoor environmental satisfaction, the main exception between being overheating in summer. But we observed reusability issues, and most of them were caused by communication and information problems. And the consequences could be quite drastic in terms of energy use and health because of hacks and adaptive behavior. So there was a significant correlation between IAQ and usability, but occupants were able to achieve comfort in spite of poor usability. And so the main problem were actually dysfunctional systems and operational failures. So the conclusion would be if we have to include more automation also in residential dwellings, building services must be more commissioned and work better, and occupants must be better informed than they are currently. Thank you very much.
Thank you very much for a really good presentation. I have a couple of questions coming to add a similar question. How did you distribute the survey and how many people took part responding? So what was kind of your response rate as well?
Yeah, so the survey was distributed to 2,000 houses. We actually sent it in everybody's mailbox. So there was a letter that was explaining the survey, there was a paper copy of the survey, and there was also a QR code that was allowing people to answer digitally, and about half of the people did that. And we got 344 responses back, which is about 17%, so it's quite low. And it was also variable from neighborhood to neighborhood because of different engagement levels of the housing association that actually distributed the survey.
Okay. That's really good. I'll probably thank you very much for your answer, and we'll discuss more in discussion time. So the next presenter, Verena and Barthelmes from EPFL. I'll let you present. So that's a short presentation from Verena. Sorry, Verena, we can't hear you. I think you've probably been still muted. Perfect, yeah.
Oh, okay, perfect. Okay, great. Yeah, thanks very much, Stephanie. Can you hear me all right? Okay, good. So I will shortly present the prototype of the mobile application OBdrive, which was developed to capture real-time motivations behind human building interactions. So basically, the prototype of OBdrive was developed in the context of our eCombine project, which is aimed at gaining a better understanding of the cause-effect relationships between occupant behavior perceptions and combined environmental factors. So in general, the eCombine project foresees a quite complex data collection strategy that includes measurements of all IEQ dimensions, the thermal, olfactory, visual and acoustic environment, as well as point-in-time surveys of subjective perceptions of the occupants. But in this presentation, I would just like to briefly focus on the tool that we were using to collect motivations behind actions from the user each time they performed a certain interaction, and so to complement, let's say, the objective data collection. So as you can see from the picture of the experimental setup, the action logs from the wireless window read sensors are complemented with these installed mobile phones close to windows and blinds. And to give you a better idea of the functionality of this prototype, there is a quick showcase on the slide, which I will start now.
This is a quick showcase of our developed mobile application OBdrive, so we can open the application and the main user interface appears. Currently the settings are switched on the interactions with window and blinds, but there is also a second layout for the interaction with desk light, which we will see in a minute. Okay, so this is the interface that the user will see close to the controls, close installed to the window, for instance. So here the app asks interacting with windows or blinds, and to start giving my feedback, I have to provide the user ID, which can be, for instance, A1. These user IDs can be predefined by the admin. So I confirmed, and as a second step, I can describe what kind of action I'm performing. So let's say, for instance, I'm currently opening a window and opening a blind. Then I confirm again. And now I can indeed report my actual motivation behind my control action, which might or might be not different from what is usually captured by the objective data collection. So let's say that right now I feel too warm, that the air is too stuffy, and that I feel like I would also boost my productivity. So I confirm. And now, why do I operate the blinds? Maybe I still feel too warm, it is too dim, and I also would like to enjoy the view outside. As you can see, there are other recurrent motivations, such as arriving or leaving, or eventually a co-worker asked me to adjust the blinds for him, or saving energy, and so on. So I confirm again. Now I'm being asked if I consulted a co-worker before operating the windows and blinds. This should give some additional insights into the group dynamics and social norms. So let's say that in this case I actually did not consult anyone. Okay, now just a quick insight into the admin interface. For this I need to put a specified keyword with a password, so that I can actually get in the admin interface. So here you can see that I can have a name for the device, which can also be window 1 or 2 and so on. I can import specific user lists in JSON format, then I can turn on and off the kiosk mode, which is extremely handy because in this case the user will not be able to get out of the application. And finally, I can export the user action and use them for further data analysis. Further, you can see that I can switch from window blinds to desk lights. So in this case, if I go back, the interface has changed. And in this case, also the motivations will change. We have a new set here. So what best describes the actions? So for instance, turn on or dim up the light. And here is a set of different motivations.
Okay.
This is a quick...
so basically in this case, of course, the app will be installed close to the desk light. So unfortunately, right now I don't have really the time to show you the detailed results of our campaign. So this will follow, but currently we're thinking about improvements to further develop this prototype, let's say. So for instance, the order of priority of different motivations, and of course, the input has to be really quick because we don't want to bother the employees too much. But sometimes it might be actually useful that the employees can give a personalized answer if the predefined motivations do not fit. And then, of course, the translation into other languages, because currently this is in English and we're actually using this in the French and German-speaking context. So that's it. Thank you. If you have any suggestions or comments later on.
That's great. Thank you very much. Looking forward to the discussion. Gary, Gary Rowe from GRPS on evaluating varying comforts. Sorry, Gary.
You remuted me. Yeah. Okay. So I was unmuting at the same time that you were. Okay, thanks, Stephanie, and all. With thanks to Paul Ajiboye and CTEC for helping with this work. I'm talking about evaluating varying comfort. And why do we want to do that? We were interested in schools, and schools are not climate chambers. They are typically naturally ventilated in the UK. The temperature varies, the activities vary, the occupants are present for a short time. And so asking a single rating, how do you feel, or how have you been feeling, really makes little sense. There are so many different answers that they could give. So we wanted to try something different, simple as possible, and to try it out. The thing that we came up with is we asked the staff in the school what percentage of the time they found it was too cold, what percentage it was too warm. And they told us separately about winter, about summer, and about the day of the survey. And also the students, we just asked them how, have you felt too hot any time today? Have you felt too cold any time today? Because how people feel, whether they say they are too hot or too cold, that's what drives their behavior. It's not about whether I define them as too hot or too cold. It's how they define their own sensation. A pilot study was in primary school, and it was a warm day in September. They answered the questions towards the end of the day, both staff and students, and we were dealing with the children aged 7 to 11. We also did some objective measurements in some rooms of thermal conditions, indoor air quality, and noise level. Now, the first thing you want from a question like this is that people understand it, they can answer it easily, and the numbers that come out look sensible. And I think we're okay on that. The summer, they're much more likely to feel too hot. The winter, they're more likely to feel too cold. And in September, it's in between. Also, the north side of the school, more likely to be too cold. The south side, more likely to be too hot. So consistent, you've got your basic level, it kind of makes sense. And also for the students, the same thing. The seasonal effect, the effect of the orientation of the building is exactly what we would expect. And we could drill down a little bit more with this technique, because we asked students in 4 different quadrants of each class, and 2 of the 4 rooms on the south side had ceiling fans for cooling. And we were able to show that those with fans were feeling cooler, particularly those at the front of the classrooms, which was interesting because there's an HVAC system that basically shoots air across the ceiling and hits the back wall. With the fans, the air mixing is better. So the cooling that we got with the fans was not just air movement, it actually reduced the temperature and also reduced the CO2 concentration. You're clearly getting better mixing of fresh air with those ceiling fans in place. And there were consistent findings also with air quality, with noise, with lighting. The whole thing made a lot more sense than we could even have dared hope for. So much I could say, but I guess my time's nearly up. So all I can say is I'd like to see further development of this. If people want to collaborate, I think there's some refinements that we can offer. But I do suggest this is a great way of doing your behavior relevant research, and also to do a first triage. Is there a problem in a particular building? This will pick up problems really quickly, because people can say, even on the same day, is it too hot, too cold, sometimes too hot, sometimes too cold. And thank you very much.
Thank you very much, Gary. That was really good. So our next presentation is by Sarran, Weiner, and it's a case study of reasons of office occupants' dissatisfaction with an automated lighting control system.
Yes, can you hear me?
Thank you very much, Sarah.
Hi, I hope you see the right screen now.
It's great.
Okay. Okay, so hello, my name is Sarah Weiner. I'm a research associate at the Fraunhofer Institute for Building Physics, and glad to present results from our case study, which examines the dissatisfaction of occupants with automated lighting control systems. In order to reduce the energy demands of buildings, building automation systems are being used more and more frequently, especially in office buildings. However, these systems are often associated with high occupant dissatisfaction. In order to get a better understanding of these tendencies, we've studied them in more detail on the basis of automated controlled lighting in German offices. A German-wide questionnaire survey from February 2019 shows that manual lighting control still predominates in German office buildings. Only just over 20% of all 365 respondents had a semi-automated control lighting in their office. This means that although occupants can control the lighting manually, it has an additional automated control logic. Only 1% of the respondents had purely automated control lighting. This option is therefore irrelevant in Germany to date. This study also shows that occupants with a semi-automated lighting control show a higher rate of dissatisfaction with their control options. Based on these findings, we asked 2 questions. What are the reasons for occupant dissatisfaction, and do dissatisfied occupants behave different than the others? In order to examine factors for dissatisfaction more closely, a further questionnaire was carried out in a typical German office building with a semi-automated lighting control, in which 58 occupants took part. In addition, the building automation data from a total of 9 single offices were evaluated to assess the occupant behavior based on measurement data. The majority of reasons for dissatisfaction mentioned here refer therefore primarily to the control logic behind the semi-automated lighting systems, which doesn't sufficiently support the demand of the occupants. The major reasons for dissatisfaction mentioned refer primarily to the control logic. Dissatisfied occupants find the automation to be irritating. The assessment of the building data shows that the automatic dimming of the illuminance level is often reversed by this group of occupants. In addition, the users show a higher interest in energy efficiency, as they would like the system to switch off automatically when the room is bright enough. The assessment of the building data shows that these occupants have so far done this manually by using the lighting mainly in the twilight hours and switch it off when the room was bright enough. So most problems we identified are more about the control logic than about losing or giving up some control for automation. Next steps in this project will be to create usage profiles of each room and use them for the optimization of this control logic. Thank you for your attention.
Thank you very much, Sarah. So we have now our last talk of the session and of the symposium by Ardeshir Mahdavi from TU Vienna. And the presentation is entitled Impact of Visual and Auditory Factors on Perceived Thermal Comfort, a Case Study.
Thank you, Stephanie. I hope you hear me today better than yesterday. So very good. As most of you are familiar, there is a tendency for most of our current standards and guidelines with regard to indoor environmental comfort to be monodimensional or single aspect. And there has been a number of efforts to try to see if we can move into guidelines or codes or recommendations that are looking at the concurrent effect of multiple sensory expansive situations on inhabitants of buildings, including thermal, air quality, acoustics, and lighting. Recently, an effort led by my good colleague Marcel Schweiker in the Annex 79, we looked at a large number of publications in the past decades on the subjects. And my very personal takeaway from that study was that these results of these studies are mostly show if there are, so to speak, cross-sensory effects. They seem to be not always very significant. Sometimes they're contradictory, so some effect in one application is supposed to increase the observed effect, in the other publication is different. So it seems to me, at least in my opinion, that most of these results are inconclusive. And the reasons for that, that most of the studies are short-term, so short-term occupancy, typically a small number of participants. The profile of participants is limited. Usually the usual suspects are students who are, so to speak, taken advantage of. And the artificial settings are usually deployed, office-like type of settings. There are, of course, also larger challenges, like how do we address privacy ethical issues when we do these type of studies? How do we deal with the Hawthorne effect? And how do we deal with the expenditures associated with these studies? We also couldn't start to address all of these, but in a recent study with Christiane, my colleague at TU, we looked at, try to address the small number of participants by having a bigger cross-section study. It's going to be something close to 350 people participating. Right now we have about 80 participants' results analyzed, and I would like to very briefly share with you the results. The research design was that in artificial office settings, we exposed the participants to different combinations of temperature settings, glare conditions as a representative of maybe stress factor in the visual domain, and also sound, which was emulated in terms of the traffic noise. So where the participants were in these offices, they could imagine that they could believe that the noise exposure is coming from outside. So different levels of those were, so to speak, practice, and the participants were exposed to in sessions. And basically the results so far are somewhat as we kind of expected. We'll not go through all of the results. Here you see the thermal sensation scale and the thermal comfort scale. And I just focus on one view of the results, this lower diagram. You can see on the x-axis the increase in exposure intensity. from, so to speak, what we assume to be lower exposure intensity, no noise, no glare, to a situation when we had, so to speak, a compilation of this exposure intensity. And here you see the thermal sensation votes. The results for the thermal comfort were kind of comparable. And here you see a kind of a tendency, but what we forget in many cases, what is the, so to speak, the distribution of the results? That is to say, what is the intergroup differences in terms of the votes as compared to the statistical tendency that we can see? And what we can see, obviously, in this study, that this diversity, even though in this case we are talking about a group of mostly students and in a limited range, is by far, surpasses the type of signal that we pick up from this study in terms of how, for example, acoustics can affect the can influence the thermal sensation, or how, for example, the glare can affect the thermal sensation. So for me, the takeaway of this study is that as long as we are not able to do more long-term studies involving more realistic settings, involving a broader demographic settings, as long as we have to do this type of short-term studies with a limited profile of the participant, we probably will not be able to get any kind of conclusive and convincing demonstration of the cross-sensory effect. So what we need, I think, is to have more long-term in situ studies. Field studies would be very important. We would like to have the contextual conditions taken into consideration, the affordance of the buildings, and I think we need a lot of collaborative and international studies. Since I'm the last speaker, I wanted to ask to thank my co-author, but I wanted to, as a last speaker, pay my compliments to Southampton team, Bach, Stephanie, Tom, everybody else. That was a marvelous experience, far beyond what I had expected. So thank you very much.
Thank you. Thank you for your presentation. Really nice as well. So we, to conclude our last open discussion, will last about 15 minutes. I've got many questions, about 13 questions at the moment, being Q&A. Just to let you know, all the questions, the Q&A are captured, and then we can share them with all our speakers as well. So you don't need to type them frantically. There will be feedback as well for all of the presenters. The session as well are recorded, so you can have a view of them at a later stage. So moving on to the discussion, I have a question starting, which is the most upvoted question, is for Verena by Marcel. Is do you have any observation whether OBdrive affects the number of interaction with window or so? Example, are participants using devices less often in order to avoid being asked the question? Sorry, you're muted. Sorry.
No, I said that is a very interesting question, and also for the example, not only if they're using it less often, but especially if they're using more often, because they're curious to see what is happening. So we gave an info session to explain the participants, and we took actually data of the window actions from the logging from the window read sensors for a longer period of time. So we haven't done that yet, but basically we can see then and compare the window opening actions while we had the app installed and while not, in order to see if it somehow affected the frequency of the response rates.
Great, thank you very much. So I follow up with some question. Another question by Clayton Miller. Is OBdrive downloadable and usable by other researchers?
Not yet. The idea is to optimize it, and then eventually we can see. So at the moment we're working with local APK files, so it is not downloadable from the Play Store yet or similar, but maybe soon.
Okay. Then on a question as well that was asked is, how did you promote the use of the app? How did you to the user?
Yeah. So, like as I mentioned before, we had some detailed info sessions in order to explain also what we mean with the different symbols, and if the participants understand actually what we mean. So basically to have like a common goal. And so we did not promote specifically the app. So we have some small incentives for the project participation.
Mm-hmm.
Yes, so that's
yeah, so that was exactly a follow-up question by Zoltan. What are the incentives for people to use the app?
Yeah.
I imagine.
What also makes it easier is that actually we provided the phones close to the window. So we installed phones and we did not ask the users to actually use their own phones, right? So this also maybe made it a little bit easier because they really just have to go there and click. They don't have to scan codes. They don't have to, it's just like an interface directly close to the control. So this might make it a little bit easier.
Very good. Okay, great. Thank you very much for all your answer. I've got now a question for Gary. How do you relate answers to questions such as in your classroom, do you remember, or to the measurement, did the students say the same, stay in the same room orientation for the whole day?
Yes, they did. For their teaching, they would be in the same room. That would be normal in a UK primary school, that they're pretty much in the same room. You'd have to do it slightly differently in a secondary school where they do tend to move from room to room.
So for me, a follow-up question is, can we use the same method for different settings? So in this panel, we had office, we had yourself school, we had residential building, we had an app, it could be a different setting. So
yeah, it's such a simple, basic thing. I'm sure you can use it in any setting. It's most relevant to where the environment is varying or where the activities are varying. And you just want to get a snapshot. You don't want to have to keep asking the question again and again and again. You want to get some idea. So you're not getting precise. I'm not saying that people know to the nearest percent how much time they were too hot or too cold. What you're getting is a semi-quantitative impression that tells you, is there a problem? Is there something we should follow up here? Is this at a level where it will start to affect behavior, which is after all what this conference is about? As one example, one of the teachers had such problems with it being too cold that she was wearing a coat while teaching and still feeling cold. So that's just an extreme example of how what they say is too cold immediately affects their behavior.
Yeah. So that was a follow-up question by Clarice Biel de Souza on can people judge percentage properly, or you ask the question, how many times during the day?
Well, I think they can answer it properly enough. I think, as I just said, we don't expect it to be precise. So that's the great advantage. You have to ask, you only ask them once. And so on the day of the survey, we could ask them what percentage of that day. We could also ask them on that time, what percentage of your working in the room in winter, what percentage of the time of working in the room is summer, and you get absolutely consistent findings that work across not just thermal comfort, but how it relates to the other environmental variables. And by the way, I think it doesn't have to be you don't have to stick with thermal comfort. You could ask about air quality. You can ask about noise. What percentage of the time is it too noisy? Is important. Not just how loud is it, but it's what percentage of the time is this driving you mad?
And I think that's a common theme. Listening to all your presentation, you had a range for me of questions which were reflective in some form. So and some questions were more at this precise moment. So it's your method is quite interesting because it's trying to capture this part of like a memory as well on the reflection. So do you want to comment on that? Do you think you should have, in standard at the moment, you have at this precise moment, but it's kind of a complement question to that should be added.
Sure. It depends on what's the objectives of asking the question. If you want to know, if you want really good detail of how someone feels, just how cold, how warm, at a point in time, clearly that directs you towards something like the ASHRAE or thermal preference sort of scale. If you want to know how people have felt typically in the past, I think you can use the approach that I'm suggesting. Or if it's an environment that is pretty much constant and people are always doing the same thing, then you can ask, what's the typical condition, again on a 7-point scale. So you match to purpose. I think if you are just trying to get a first idea, is there a problem in this indoor space or indeed outdoor space? Here is a really simple, straightforward way of doing it.
Mm-hmm. Oh, very, very interesting. So one question now is for Professor Mahdavi. Despite the few studies available, is there evidence that positive sensation can compensate for negative one in other domains? What would be your hypothesis about this? Thank you. And that's from Mark's Syndicus.
Yeah, I think that's a great question, because in my experience, aggregate judgments about a situation, if you ask people, as you just mentioned, is not necessarily fully instantaneous. Mm-hmm. Of course, if you hear a big noise at a certain point in time, you can ask people if that was pleasant or unpleasant. But if you're asking about their evaluation of a certain situation at a certain point in time, it has either a short or a longer history that leads to that aggregate judgment. And it seems that aggregate judgment is not just, if you want, determined by the physically measurable factors of the environment, but also with the associations that people have. There was a nice presentation, our colleague in the acoustics, where she said the attitude towards the neighbors has some effect on how you evaluate the noise emanating from the neighbors. This is something that we know in the last 34 years. So yes, I think the question is, if we exclude this, what I refer to as informational aspect of the stimulus versus cognition process, if we exclude that, we just miss on those variants that is based on that. We just looking and trying, like engineers as we are, we try to say, we got to be able to predict this. Well, we are not, because those boundary conditions in terms of attitudes, in terms of the daily situation, mood, and so on, plays a role. So I think what we can do, as colleagues some years ago suggested, to develop something like a performance plateau, that we say there are a certain combination of variables that generally, if there is no interfering factors, are deemed to be acceptable. And as long as you're in this plateau, the risk of, so to speak, having very negative judgments is low. But within that plateau, you got to be willing to expect that under certain conditions, people will find the situations unpleasant, uncomfortable, or undesirable. And that is something that I think we should take into consideration.
Yeah, a very good point. That you have a much more holistic view of our environment we are. I have a question for Lucile from Clarice. To what extent your study is showing occupants were misinformed about how much control would they have, i.e. if they were told in advance the limitation in control, would they show the same level of dissatisfaction?
Yeah, so that's a good question related to expectations as well, I guess. And I guess, so one thing is that the people that filled in the survey, that had been living in these houses for 1 to 5 years. So that's also why the study is called Learning to Live in a Low Energy Dwelling, because there was a learning process and most of them went through it. So I can imagine that at the time of the survey, whether what they were told in the beginning was maybe not that important anymore, but it was, however, mentioned by some of the respondents, especially the ones that had just moved in, that they like they were told very little about what this ventilation system was. For example, they had never had that before, and they were told very little about the trade-offs, about the advantages of it, about why they should not turn it off or tape it, and all of these kind of things. So that definitely had an impact on their satisfaction. They were kind of left without information and knowledge, and I guess that's quite common, unfortunately.
That's a very good point. About capturing user satisfaction, it's I have a question for Neil. Did you notice if there were certain type of polling station users? For example, were they users who were predictable versus volatile versus mixed? Did you try to cluster people according to their feedback?
Yes, that's a good question. I did notice that they were very different, and there were, I guess, different people profiles. Unfortunately, for the polling station, we don't know. We can't connect each vote to a individual, so we don't know who entered which vote. We only know what we asked in the survey, where we voted. So in the survey, we can match their satisfaction vote in the survey and how often they vote, and also how satisfied they were with thermal conditions, for instance. Okay. So no, we haven't done that kind of analysis, and I don't think it would be too interesting because we have so little data. We looked at some demographics, so people vote about as much as men, young people vote about as much as old people, and so on. Then nothing very interesting there, but dissatisfied people voted a lot. That's for sure.
Okay. So thank you very much, all the panelists. I think that was really interesting. The range as well of methods that you all used in studies. It was all empirical work, and I think that's really conclude this session. There are many other questions. I think we got another, very sorry, another 8 unanswered question, but I say all of this is captured and will be, Neil, you have a lot of questions for your PhD as a feedback. So yes, so with ready to close this session. Thank you.
I would just add, sorry to bother you, Stephanie, we've now got the closing remarks invitation to expert meeting. If others want to just give a typed answer, feel free to give a typed answer. But as Stephanie says, the questions are collected as well. Yeah,
exactly. So you can type answer as well to all the open question while I give ready. I want to thank not just all the attendees who have asked question and the panelists for 2 days session. I hope you had a great experience, and I hope in the future we might have other meeting online. I had in the last few days, many have reached out to Philippe and I and Bakar and asked to participate in our meeting, and we're quite grateful that he was online, because for a funding reason or personal reason, they wouldn't have been able to attend a face-to-face meeting. So maybe, as I say, be inclusive and have this kind of mode of sharing knowledge and sharing our work is really quite welcome and would be great in the future. But with further ado, I see Bakar just joined. Bakar, do you want to say just a word for just the closing of the symposium?
Sorry, can you unmute yourself, Bakar, please?
Let me just get myself sorted out here. My presentation, it's not there. Okay, so I can share my slides now. I can't share my slides. Share screen. That. Can you see my screen?
Yeah, it's great.
Okay, so basically you're seeing the wrong screen, but there you go. So basically we had 3 sessions, well, 3 sessions today, I think. And these are the ones that are around, and these are the minutes, and also the maximum views that we have, and these are the speakers that we have captured. And you should be proud of yourself. 26 countries, so this is the map for the 26 countries. I'm not really sure how many of you will be around at the end of the expert meeting, and Andreas may have also something to say about what I'm going to say in a minute, which is basically the banner for the Annex 79, which is going to be presented to the next chair. And I think we leave that, is it Mikhail, I think? So this will be presented at the end of the Thursday meeting. But to let those people who are not attending, that this is going to be happening as well on Thursday. So I'm going to stop sharing my screen. And to let you know that, there's Andreas, to let you know that after really 2 good fulfilling days of quite a lot of intensive papers, 8 minutes and 10 minutes, everybody stuck to time, and also the 2 minutes, it really worked very well. The questions and answers worked very well. I'm very surprised because I don't really believe on digital platforms, but there you are. Nevertheless, from my point of view, we are very satisfied here. We're really happy to see as many of you attending this meeting. And I hope that you'll be staying on so that for those who have been invited, so that Andreas and Liam could also talk to you about what's happening in the next 2 days. And I'll leave it to Andreas and Liam to talk now. And thanks very much for me, and goodbye.
Thank you very much. I'll echo that. I thought the last 2 days went flawlessly and actually very wonderful. And it's good that we had such a great participation. I see lots of new faces, so that's really good. So I think if there's a silver lining, it's that we reached out to a lot more people. And I think it's slightly ironic that a few of our Italian colleagues wanted to do a survey for this meeting many, many months ago to assess the carbon footprint of the trip. And I guess the answer is it's probably not very big, but would have been interesting. So I'd like to thank Bakker, Stephanie, Tom, and Philip for the really brilliant execution for this symposium. And also to the chairs and presenters who, again, really coordinated things well, answered questions, to all the audience for asking very constructive questions. Unless Andreas has anything to add to those thoughts, what I would like to do is go ahead.
Actually, not really.
Okay.
Team did a wonderful job, and yeah, it's kind of probably even frightening how well that works, having an online conference instead of coming to a place. This is actually not to say that we wouldn't have loved to be in Southampton and meet you in person and have a few pints in the evenings. But anyway, we will do that later on, and yeah, it worked very, very well.
That is the deal. So everybody listening must be a witness to this.
There may be questions about what's happening the next 2 days. So if you're new to the Annex concept, usually we have the symposium before the meeting where the work actually gets done. And the symposium is very open, and everyone presents new ideas and so on. The Annex meeting is not really conference style, although there's a presentation, but it's a bit fluid, but we are about a third of the way through the Annex. So hopefully you can see my screen, and it has the agenda. I thought I'd just give a quick overview of what we can expect in the next 2 days. So first, well, we will start at approximately 10:45 UK time. So a little bit earlier than this morning, which is not great news for the North Americans, but probably beats jet lag. And so we will start with an overview of what is Annex 79. And then we will hear from the 4 sets of subtask leaders on what each subtask is working on, what's been discovered, what's the upcoming tasks or activities for the meeting and beyond. We will do a group photo where we'll ask everyone to share their video, and we will have the first ever Annex 79 online group photo, which should test the capabilities of the system. And then after that, there's breakout sessions. So for the breakout sessions, it will be much like today, except that people will divide into breakout sessions according to their interests and what they're signed up for and whatnot. And the way the system is set up is that our hosts at Southampton will have to manually put you into breakout sessions. So it won't be that easy, although possible, to switch between breakout sessions. So what they've asked is that tomorrow you put a number at the beginning of your name, yourself, put a number at the beginning, and then they can figure out very easily which breakout session to put you in. And the remainder of the meeting has us going between the breakout sessions and the plenary. Although for the rest of the day tomorrow, it will be the breakout sessions. And then the last day, we'll follow with likely a quick plenary and then breakout sessions. And then we'll all come together to talk about what did we do, next steps, some dissemination issues, and so on. So I have a question for Philip and Tom. Did I miss any technical details?
No, I guess the one thing I just want to add to it is that this period it was, go to one meeting, then leave, join another meeting. And here we've given lunch breaks, but in order to assign you to the rooms, we ask that you remain in the meeting with the name. But it will still be a lunch break, so you don't actually have to be at your computer, but for that whole day, we'll be within just the one meeting.
Perfect. And I believe the link to join is in the program online, is that right?
Yes, and we'll be sending out a reminder email tonight to all those that have registered, and in the program, it also will have the link. There's an updated program.
Wonderful. And if people didn't register for the meeting and have suddenly realized that they would like to contribute actively, do they have to manually register or?
So registration is closed. If you haven't registered in that time, please email either energyandcities@soton.ac.uk or Stephanie or Backer, and we will manually register you and send you the information. But if you haven't done that, please do email us as soon as possible.
Perfect. And of course, everyone is welcome to join.
Yes.
I just wanted to warn that it's not exactly conference style like the symposium is.
No, it's completely correct. It's completely correct. It'll just be in a generic Zoom meeting. And so everybody, when they join, will have access to camera and audio, as opposed to in this where you are attendees or participants or panel.
Perfect. Andreas, anything else from you?
Well, just to add, the first little challenge will be the roll call tomorrow. So.
But we have a plan.
Yep. No, nothing to add.
Perfect. Anything from the hosts to add?
I think to say thanks very much to both Liam and also to Andreas for their support, and also encouraging us to go ahead with this, which we feel was really quite helpful to all of us. We will be sending an email about the last 2 days, just to give you them a sign up and some indication about how many people attended and so forth. And also a link to the meeting tomorrow and so forth, to ask people to be aware of it with the links in it. And also for those who have not registered, where they can send an email to. So the information will be flowing out straight away when we finish this meeting. But it was very, very good. As I said earlier at the beginning, I've never had a meeting like this, and it was exciting. And I think we'll repeat that if this time, if we have the same conditions imposed on us. Otherwise, face-to-face is better for me.
Wonderful, thank you. So in the tradition of IEA, I hope everyone goes to have a drink and good food. After all, the E unofficially stands for eating. So thank you all for joining, and we'll see most of you tomorrow.
All right.
Great.
Bye-bye then.
Bye.
Bye-bye.
Cheers, thank you.
So Philip, do we stay in to just talk about the roll call?
I think it would be quite useful if you and Liam could stay. I'll send you a message. So we just wait until the others, so maybe exit this, Philip, and try it again.
Yep.
Yes, or we can just go into a standard. So in that email, I popped the standard meeting details.
Which email?
Well, no, okay. I'll just close this meeting and then open up the webinar again. That's fine. Don't worry. So just re-click on this webinar. But thank you, everybody else. Just closing the meeting now.